My name is Steve Schlehuber. It's my pleasure to present you with the information for this webinar where we will be talking about undercuts and what that means for time to market and design. I work with many designers and engineers daily. We discuss the impact undercuts have on their parts, and for years I've been on the ground floor seeing the undercut design come to life. It's an exciting process, so we are going to get started. All right, so the first thing we want to do is we're going to go over the agenda. Let's get a preview of what we're going to talk about. The first thing is just defining and kind of understanding what is an undercut. Secondly, we want to talk about the purposes of undercuts, why we see them in our design, why we see them as a part of the process. Thirdly, undercut requirements. There are some specific requirements that we have to take into consideration if we have undercuts in our part design. Fourthly, we're going to talk about the challenges of undercuts. We all know if we have design parts, there are some challenges that are involved, especially on the molding side of it. So we're going to dive in and we're going to talk about a few of those. We're also going to talk about overcoming undercuts. How can we use our design knowledge that we get from things like this to try to overcome some of those challenges and maybe even reduce the amount of undercuts that we have in our parts. And lastly, we're going to leave you with the top 4 tips. We want to make sure that you leave this with something that you can take and hopefully use when you're designing and engineering whatever your part or assembly is. So first thing is, what is an undercut? I'm going to give you a simple definition of this. An undercut is essentially a feature of your part that we cannot capture with a cavity and core. We have this cool little illustration that you guys are looking at right now. You see a little hand load or side action that gets pulled off, and that little feature that it makes, that's an undercut. These cavity and core comes together, and when it pulls apart, it cannot grab a hold. That part is die locked because it can't be created by one of those. So to give you a little more of an analysis, we're actually going to go through, we're going to take a look at a couple of parts so you guys can see some real live parts, and this will hopefully give you guys a better understanding of what we mean as far as an undercut. So for this one right here, this is a medical part. It has a couple of key features that we're going to focus in on. The first thing is these barb features. These are a classic undercut that we see a lot of times with medical parts, and the reason is they're necessary. This has some tubing or something that's going to go over it. These are critical features. However, these are not in the line to draw a cavity or core. So what we do is we use side actions or hand loads to be able to create anything that's under these barb features. Most barb features don't want a parting line up here, so we can basically tag in right underneath. And also this section under here, along with those barbs, that's creating another undercut. Also on the inside of this, we're going to look, and this is a unique undercut, we see a thread. This is an internal thread, cannot be captured by the cavity and core coming down on top of this part, and because of that we need to use a hand load or a side action that we can screw or unthread out of this part to create those features, because if you look down behind each one of these threads, that's a die lock situation, so that's considered to be an undercut. Alright, let's look at one more. Now this one's a pretty complex little part, pretty simple by nature. It's a housing, almost looks like a little cell phone or tablet housing, and it has a lot of undercuts going around the outside. Obviously the cavity or core is going to come down on top. We want to keep this as flat as we can within the mold, and then all these little features going around the outside, those are areas that we cannot capture with cavity and core. Those are considered to be undercuts. Whether they're little button features or they're little portholes. This obviously has something slide into it, and then we actually have a little hinge feature over here. All these little areas are considered to be undercuts. Very functional to the part design and what they're trying to do with the assembly. Ultimately for this molded part, it makes the mold very complex simply because we cannot create these. Also, you can actually see some little recessed areas here. We won't be able to capture those areas from the outside, so those are going to be considered internal undercuts. Those are areas inside the part that can't be got from the outside. So that's just a different version of an undercut, but it's internal, and these are considered to be external. All right, so we're going to go back to the slide here. So what are the purposes of undercuts? The first thing is we're going to create some interlocking or snap and latch features. Any of you guys out there that have worked with designing any clamshells or housings that kind of move together and you want some type of snap, some easy assembly once you get all the guts of the part in there or the assembly, you want it to be able to click together. Snap and latch features are something that we very commonly see, and we're actually going to discuss these a little bit further along into the webinar, but that's one feature that we look at. The second would be side holes or ports on housings. We just looked at that very complex part. Had a lot of side holes, a lot of ports. Usually an assembly is going to have some type of wire maybe that comes out of it. We see a lot of those little holes just to extend something in and out of whatever your assembly entails. The third one is creating vertical threads and barb fittings. We actually just looked at both of those as well. I know we looked at an internal thread, but these can also be the same for an outside or an outside diameter thread. As long as it's not within the cavity and core line of draw, it's going to be an undercut, and we're going to need side actions or hand loads to create those threads. Same with the barb fittings. Every now and then we do get those where they are in the line of draw of cavity and core, but if they're not, just like the part that we saw, they're going to require hand loads or side actions. This is a unique one to provide threaded and custom inserts that are not in the line of draw. If any of you guys watched our insert molding webinar that we did, we talked about custom inserts and the ability to actually create those with side actions or hand loads. The insert itself could provide you with an undercut on your part. If it's essential to your design, there are ways to make that undercut happen, and it can a lot of times create undercuts. Many people think that threaded inserts can only be provided in the cavity and core simply because they're easy to load on. However, we get a lot, I've talked with a lot of designers and engineers that want to work threaded inserts into different directions of the part, and that's totally possible the same way any other undercut's created. So I would definitely encourage you, watch our insert molding webinar if you didn't get a chance to. It'll give you some ideas about how you can implement those into your design. And then lastly is just keeping the functionality of your design intent. Many people, they're in a rush to get this project done. It's time to market. They really want to make sure that they are holding on to their original design. And instead of being forced into, a rigid redesign process that you got to, it could take days to try to figure out how you're going to remove these undercuts, keep your design intent. Design it as you dream it and get it in fast, get your tool built fast, and that's going to keep you on the right track so you can test this, you can get it in the hands of your customers. So undercuts are complicated, but yet they could be necessary for the function of your design and your project. Now let's talk about the undercut requirements. What's required? We talked a little bit about this already. You've heard me mention it, hand loads, side actions. These are really the same thing in one. Hand load just means we hand load an extra loose piece within the mold, and side action is just kind of a version for something coming in from the side, creating a feature and being pulled out. Essentially, this is just a loose piece within the mold. Now, for these hand load and side actions, another requirement is that we have to have space within the design to have a hand load or a side action. Specifically, a lot of this comes down to whether or not you have an internal undercut. Okay, we got another little feature here that I'm going to show. So we need something that's easily removable. We don't need any obstructions. So as you can see over here on this little right one, this is your part in orange, and this little piece right here, this is your hand load. And what we have is an internal undercut within this part, and we have to pull that little hand load out. So this hand load is going to get pulled in this direction, but what we see is we see a little boss or something right behind it, and what happens is that piece becomes die-locked in there. Internal hand undercuts they're possible, we can do them, however we need to have enough room to be able to pull it out. And this kind of leads into our next point when we talk about tight shutoffs. If you saw our undercut, or not our undercut, our insert molding webinar and also our overmolding webinar, we talk a lot about tight shutoff. Anytime you put any loose piece, whether it's an overmolded part or a substrate, an insert, or even a hand load into the mold, we want to make sure that we're keeping it as tight as possible. We have to have good shutoff on the cavity and core. So when you're thinking about your design of your parts and how you're going to function in that hand load or that undercut, we want to make sure we're reducing parting lines. We want to make sure we're reducing flash. And the tighter that we can hold on to that hand load and the more space that we have within your design, especially if it's an internal undercut, we know that we're going to be able to grab onto that hand load a lot more. When you have a hand load that's kind of just sitting out there in the dead space of your part, what happens is you get a lot of pressure from the material, and just like it could move an insert or move a substrate on an overmold, we get that it could possibly move a hand load as well. It's a loose piece, so anytime it's not cavity or core, the pressure of that material has the ability to move it one way or the other. We actually have a really good example of this where a lot of times we'll get actual parts that are long tubes or they have long inside cores to them, and we need to have pins that come together and shut off on each other. And we actually like to use a method where we telescope. We'll take a female pin and a male pin and we'll put them together, and when that plastic flows around and the pressure starts to hit those pins, that'll hold it together. It'll keep us from getting flash on the inside. We see a lot of cannulas or syringes. They have very low draft angles on them, and we have these things coming together to make these undercuts on the inside, and we'll telescope them. We'll make sure they don't move around, so that way if we have any processing needs afterwards, we're able to keep those right in place, reduce that flash or parting line. So what are some of the challenges that we see with undercuts? Non-drafted areas are a difficult one. When we're demolding these parts, if you have an undercut, that means we have a side action or a hand load. We have to be able to pull that, whether it's manually or auto. Most of the time, if we're trying to do things quickly, you want your parts as quick as possible, we're going to make a manual hand load. It can be difficult to remove if we don't have very much draft. A lot of times we do recommend coated hand loads. This is a nickel plating, and what that does is it actually really breaks the bond between the hand load and the actual material that we're using. Some materials are ultimately much easier to pull from than others. You have your polypropylenes, your HDPEs, LDPEs, PBTs, ABS materials. These ultimately are a little bit softer materials, so we can pull a little bit easier. We don't have to have as much draft on those areas. However, when we get into glass-filled materials, polycarbonates, high temperature materials, these can become very rigid, they can be very hard. And it seems like every time we get a part that uses one of these materials, we have very low draft areas. They can be a nightmare when it comes to the demolding process. So when I talk to an engineer or designer, we talk about DFM, what challenges we can face with undercuts. A lot of times we have this conversation. Let's put as much draft as we possibly can and try to help us out on the molding process. Cosmetic surfaces also come into play. Undercuts can be placed all over a part if you want. However, if that's a cosmetic part, it can become very challenging to get a final part that you can hold in your hand and feel confident about as far as having a customer see it. We always use the example of cell phone case. We get lots of people, lots of designers and engineers that bring cell phone case designs to us. If you pull out a cell phone out of your pocket and look at your own, if you got one, you're going to see buttons, you're going to see ports, you're going to see holes. There's a lot of different things that plug in and out of your cell phone. The key is it's a very cosmetic part. Everyone holds it in their hand. You want to reduce the amount of parting lines that are on the outside. So if you can take those from the outside, put them on the inside, that helps out. And we're going to look at that in just a second. However, keep this in mind, that is a big challenge when you're thinking undercuts. A lot of times you're going to see this. And we're going to get into talking about overcoming some of these undercut challenges. And what I want to do is I actually want to show you a quick design feature where we can look at one part and then look at another one. And this is going to hopefully help you guys when it comes to actual design of parts. This is a little housing. Like we talked in the very beginning, I said we're going to come back to it. Snap and lock features. You know, these are very common, especially on parts that are clamshell. You want them to come together, but you don't really want them to come apart. We see these little snap features right here. These are undercuts. We have to use hand loads on the outside of this part to create those. It's the only way, based on cavity and core of this part, that we're going to be able to create these. And we see them pretty much all the way around this part. Now, for the same feature, I want us to go back and we're going to take a look at a different design. Now, the person who designed this part actually took a different approach. They have the same type of clip features that are going to be used on this part. However, what they did is they actually, what we call window out. So they windowed or put a little window into this feature coming down from a cavity or core, and it's going to come all the way down to hit the top surface of that clip. So instead of having to have an internal hand load to create this clip down here, essentially they changed it and they made it into an open and closed part. This is a great design, and as long as your design allows for you to be able to open this up, now we understand sometimes it doesn't. You might have, you know, a barrier seal, or you can't have a liquid or something like that get into it. That's fine. But if you do have the flexibility, you can use this feature, window it out, we can capture it by cavity and core, and we essentially just eliminated some costs for you. All right. So now we're going to go back and we're going to talk about some other different ways that we can use to overcome undercuts. And we actually have a couple of examples here. Undercuts add cost. There's no doubt about it. It makes your tooling more complex. A lot of people, probably one of the #1 questions we get is, how can we get rid of them? How can we avoid them? We understand sometimes you can't, but in these cases, hopefully these design techniques will help out. This first one right here is basically just a hole in the side of this housing. Very simple. And this one right here, we got a couple of different rectangle little pieces, cutouts on the side. We're going to pull those out. On the bottom here, we're going to look at a couple of different ways in which we can try to reduce them. This one right here, we have the same little hole down here on the feature, except for what we did is push this wall back a little bit, and we open this up all the way to the thickness of that hole. And what that does is it allows, just like we looked at with the clip features, for cavity or core to come up, create that little hole feature, and now you still have your hole, but you also created a design that is now open and closed. You saved yourself the cost of having a little bit more complex tool. Same thing for this one over here. You have this little version that you can kind of cut out all the way up to this point where we can get cavity or core to come through there instead of having a side action to come in and out. So it's really important when you're thinking of undercuts, if you're trying to get rid of them and try to avoid them because of the cost, you want to make sure that you're thinking about cavity and core. I would really I talk with my designers and engineers all the time about, you know, what's going to be the cavity and core on my part, so then I can get to that point of designing it the correct way to try to reduce those undercuts. So hopefully this is a design feature that can kind of help you out with that. Now we're going to leave you guys with the top 4 tips from today's webinar. The first one is keep obstructions away from undercuts. Give the molder or tool maker as much room as you can get on that design. If you can't, there's still usually a way to be able to get it done, but it makes for an easier molding process. Ultimately, remember that hand load could be just a little bit bigger than your undercut. We need to connect it somehow with the cavity or core or hold it in place. So it's not always just the size of whatever your undercut is. It could be a lot bigger than that. So we need some room to move. So keep that in mind when you're putting bosses and stuff like that close to where you have an undercut. The second is reduce undercuts on show surfaces to cut down on the parting line. We use the cell phone as an example, but there's a lot of other different parts out there that are cosmetic that have undercuts, and sometimes they're on the show surfaces. My biggest tip on this is try to put them on the inside of the non-show surface. So if you have a housing and it's on the outside, if you can find a way to draft it so we can pull that hand load or side action from the inside instead of the outside, that's going to reduce that overall parting line on the show surface of it. So try to cut down on that, or try to implement more than one into one location on the part. That can cut down on the amount of parting lines that you have. 3 is use draft to help facilitate the undercut removal. Think of it just like your regular part. When we're pulling a piece of mold from it, it's just like the ejection out of a cavity and core. We love to see as much draft as we can. If you can't, like we said, there's coatings and things like that that we can use on these undercuts to make sure that you don't lose out on time. Last thing you want to do is sit there and try to have to redesign everything. So there are ways to get past it, but if you could think about this in the beginning stages of your design process or engineering process, it helps a lot in the molding process. And what you want is you want to see those parts quick, and this helps us get through that molding process very quickly. Lastly, consider side actions for custom and molded inserts. This is a good one. This is a good tip because it allows for you to increase your arsenal on the design side. Don't limit yourself in terms of threaded insert, custom inserts. We know they create undercuts, but they can be done by using those hand loads and side actions. So make sure when you're thinking of design, you're thinking of your intent. Just make sure that you guys are considering that in the process.